Okay, tomorrow in class we're going to be discussing the theorem that says congruent chords are equidistant from the center of the circle. Right? We know what congruent means. We know what chords are. They're segments with endpoints on the circle. Equidistant means the same distance or equal distance from the center of the circle. We also have the converse, which just reverses that statement. Chords equidistant from the center of a circle are congruent. So if we know that they're the same distance from the center, then they are congruent. So we're going to be applying that theorem to these problems. Now we want to look at these two examples here. One example, the chords are equal, and the other example, the chords are not equal. Look and see if you can decide. Would CD and EF be equal here? Or would JK and LM be equal? If we look, here's our center. We know that the distance from the center of circle Q is going to be congruent to the CD, and the distance from center Q is congruent to segment chord EF. So those chords would have to be congruent because they have equal distance from the center. If we look at example 2, we know the distance from Q to chord JK is 9, and the distance from Q to chord ML is 8. Since those are not the same distance, that would not be congruent. Now we want to put that to work. We want to find the length of AQ. Here's AQ. I know that chord DE is 18. I know that chord GF is 18. So I have congruent chords. If I have congruent chords, then they must be the same distance to the center. So I look at my center. I know the distance from the center Q to chord DE is 7. So the distance from Q to chord GF must also equal 7. In the second example, I can tell that the distance from Q to chord KL is 4. And I can tell the distance from Q to chord JH is 4. So I want to find the distance from H to J. H to J is a chord. And if they have the same distance to the center as K to L, which is equal to 7, chord HJ must also equal 7. Okay, let's work this one. I can tell from the picture that the distance from the center Q to Y is the same as the distance from center Q to YX. So they have equidistance to the chords. That makes the chords congruent. The problem is I don't know what either chord equals. So I've got to work it out. Now I like to put my larger X term first because I like it on the left. So I say 35X minus 16 equals the other chord, which is 31X. And I got to use my algebra to solve this. So I'm going to subtract 31X from both sides. I'm going to match it up with its like term. So that tells me 4X minus 16 equals 0 because 31X minus 31 is 0. So if I bring that up here, I have 4X minus 16 equals 0. So to solve this, I need to add 16 to both sides. So I'm going to add 16 to both sides. Those cancel. So 4x equals 0 plus 16 is 16. And then finally, I want to isolate the x by dividing by 4 on each side. 4's cancel. So I know x equals 4. So I found the value of x. X equals 4. Now I want to find the length of xy. So I've got to substitute my 4 in for my x. So that gives me 31 times 4, which gives me 124. So x equals 124, and the length from x to y, or x equals 4, and the length from x to y is 124. Make sure you answer both parts of the question so you don't get half off.